Assalamualaikum students, welcome to another video of study with ARS. Today's our topic is bone energy and strength of bone. So going with the bone energy, bone energy. So basically the definition of bone energy is the energy required to remove the energy required to break the bond. Means to break the bone. Wait, I'm writing here. Energy required to break or to form the bond, to break or to break or to form the bond is called bond energy. Okay, so one thing I've said here is wrong. You will say that why I have said here which is wrong. What is the reason that you are saying it wrong? I will be telling you why. Formation of bond and breaking of bond. Okay, breaking of bond. Why I have said here, and the thing which I have said, which is a wrong thing, is this that the energy required to remove the required to break the till here it is right definition, and here or to form there will be not or. Why? Because whenever there is a formation of bond, there is a release of energy process take place. Means an exothermic process takes place. What is exothermic process? Will tell you. Wait, exothermic process. Okay, what is actually the exothermic process? So the exothermic process is release of energy or heat. Release of energy or heat is called the exothermic. Okay, so the release of energy is called the exothermic, and formation of bond is an exothermic process. So cause of that, the energy which will be released will be calculated as the bond energy, and here there is a different case. The energy which will be given to atoms to get bounded, and that energy will be called as bond energy of the particular molecule. Okay, so here formation of bond, for example A atom and B atom. Okay, so they want to form the bond. Okay, so first of all they will be forming in three process, and other means likely same process. For example, they are having a distance of 5 angstrom. Angstrom is the unit of distance. Okay, so what they will do, they will be uh, uh, trying to means attract by themselves with an energy. Okay, and will try to means decrease the distance between each other. Okay, and for example now they are having the distance of 3 angstrom. Okay, so again the more energy will be giving, so the it will form like this: A B, and now it's a bond. There's an electron of A and this is B, and the bond has been formed. And bond, first bond is called sigma bond. Okay, but do not go here. Okay, so here we give a bit more energy, and then the bond will form. Here we give third type of energy, here second type of energy, and here we give first type of energy, and finally the bond has been formed. Okay, by giving this energy, for example this energy was 200 kilojoule per mole. Okay, you may say, and this energy was 100 kilojoule per mole, and this was 50 kilojoule per mole. Okay, but in the end the bond formed after giving the energy of 200 kilojoule per mole. So this energy will be called as the bond energy of atom A and B of AB, which is a bounded, and the ever compound has met will be called as the bond energy, means this one. So for example, uh, hydrogen hydrogen will form H2, H, H. Okay, so the bond energy of hydrogen is 436 kilojoule. Wait, I want to change my pointer. Okay, I've changed my pointer, so now let's go for here. Means H, hydrogen, and this one is another hydrogen. Okay, and for example, they wanna form the bond, then what they will be doing? Okay, there's a plus sign. They wanna form the bond, then they will be coming together and will forming by sharing their electron. Okay, and will form the covalent bond. This bond is also called single covalent bond, and the nature of this compound, the nature of this molecule is diatomic molecule. Okay, so now the energy required was 436 kilojoule per mole. Okay, this was the total energy which was required. So cause this energy was required will be called as the bond energy of H2 molecule. Okay, means the energy which was required. And now let's go for breaking of bond. Okay, so here for example HCl is there. Okay, let's look at not means particular example. Let's look at the example of atom A and B. We miss this one which we have formed the bond here. Now I want to separate atom B. Okay, so what I will be doing? So simple thing which I will be doing, I will be, first of all let me tell you one thing. There's an endothermic process. Endothermic process. Okay, means we will be giving the energy. Okay, so cause is this no this one, the energy will be giving, and here the energy will be released. Okay, while forming the bond, this energy will be released, plus delta H. Okay, this energy will be released, and the release of energy is also called minus sign, because the energy has been released, it is not be storing. And this process is called the endothermic process. And endothermic process means the we have observing absorbing of energy is endothermic. Endothermic thermic having a positive sign. Why it is having a positive sign? Because it will absorb the energy, and exothermic will release the energy, and that's why we are having a negative sign there. For example, I want to separate A and B from this bond, then what I will be doing, here is A and B, so I want to separate the bond, so I will be giving the heat here to separate the bond. Okay, so for example, the heat was released from combination of these two was 200 kilojoule per mole. So I will be giving the same energy 200 kilojoule per mole to break the atom. Okay, then it will be called as A plus B. Okay, so both are now being separated, and this energy is been called as the bond energy. Okay, so now let's look at the means relationship with bond energy. So bond energy is having a relation with, means the higher the bond energy is, the greater the bond strength is. For example, uh, bond energy is directly proportional to bond strength. Okay, this is means you may say a law created by no one but me. Okay, the bond energy is directly proportional to bond strength. The higher the bond energy is, the higher the bond strength is. Okay, and bond energy also depends upon bond energy also depends upon the electronegativity. Okay, the higher the electronegativity is, the strong the bond will form, the strong the bond energy will be there. Okay, for example, like HCl, we are having charges, partial minus, positive plus, partial plus. Okay, so now they are in an ionic form, is they are trying to they are trying to snatch, chlorine is trying to snatch the electron because of electronegativity, and this one electronegativity. Okay, electronegativity is the means power to attract the shared pair of electron. Okay, so chlorine will try to snatch the electron and will get a partial negative, hydrogen will get a partial positive, and now this bond will be a stronger cause is this that causes this that they are means having positive and negative sign, and positive and negative sign will attract together. Okay, negative will attract, suppose that bond energy is directly proportional to electronegativity. Now let's look at the first and at the last and ionic character, because I don't know what will be your life, so that's why last time. Okay, ionic character. So ionic character, what would be the definition? When the when in an covalent bond charges appears the charges called the ionic character of a of covalent bond. Okay, so the example is there, but now I have to draw it again. Okay, I'm giving another example, and wait, this is not a partial. Okay, for example, this one, HF, hydrogen fluoride. Okay, here the electronegativity of fluorine is 4 and the electronegativity of hydrogen is 2.1, and fluorine will try to take the electron and will try to snatch the electron and will get a partial negative, and hydrogen will get a partial positive, and this one uh, process will be you may say will be we will be discussing an ionic character of covalent bond, because this was a covalent, and then the charges appear, so that charges between the covalent bond will be called as the ionic character. So this was today's topic. Hope you guys have enjoyed. We will see you in the very next video.